The U.S. Navy is racing against China in a naval arms race. The plan for 2026 alone is stacked with new submarines, destroyers, amphibs, and oilers. But how are new naval ships actually being built before being sold to the U.S. Navy? Before we get started, make sure to hit that subscribe button and let's get into it. So let's walk the process the same way a shipyard lives it, step by step, in real places. The first stop isn't the waterfront, it's the design stage, where design maturity decides whether the whole program stays on rails. This is where people get it wrong. A warship isn't just where you mount a radar. It consists of power loads and cooling demands. It's all about shock hardening, cable routes that have to fit through passageways you can actually crawl through, maintenance access, because sailors will be the ones opening panels and reaching valves in heat and motion for the next 30 years. If you start building before those interfaces are stable, you do not go faster. You build it once, then you open it up and rebuild it again. Once the design is ready enough to build from, the contract gets awarded and the shipyard becomes a factory. Now, you're on the shop floor. The steel plate gets cut, formed, and turned into structure. The ship does not grow as one continuous hull from bow to stern. It grows as blocks, huge modules that look like building sections of a metal apartment complex. And the smartest decision in modern shipbuilding happens right here. The yard outfits early while everything is still open, because installing the guts of a ship is either easy now or miserable later. In an open module, workers can stand over the job, run piping clean, mount foundations, install ventilation trunks, and route cable trays in straight lines. Wait until the ship is closed up and suddenly you are trying to thread systems through access hatches like you are repairing a washing machine from the inside. That's why shipyards fight for early outfitting. It saves time, saves rework, and saves the crew from inheriting a ship that feels impossible to maintain. Now move to the big yards where this modular approach is the entire rhythm. Destroyers are the cleanest example. The Arleigh Burke class and the Zumwalt class may look like different philosophies from the outside, but both rely on modular construction in large shipyards like Bath Iron Works in Maine and Huntington Ingalls facilities in Mississippi. Instead of building one ship in one piece, they build sections, outfit sections, then join sections until the hull finally becomes one continuous shape. And the scale matters because it changes what building a ship even means. A modern guided missile destroyer is about 509 feet long and about 66 feet wide, with a displacement around 9,300 tons. It can carry a crew that pushes north of 300 sailors depending on the setup. That means the yard is not just creating a hull. It is building a floating system that has to support hundreds of people non-stop in heat, noise, and motion, while also powering sensors and combat systems that demand stable electricity and steady cooling. Now here's the next place you walk into, the integration phase. This is where steel turns into a ship that can think. Once the modules are joined and the hull is assembled, the ship moves through heavy outfitting where major systems get installed and connected: sensors, combat, electronics, propulsion components, all the things that make the ship more than a floating shell. In destroyers, one of the most critical installs is the Aegis combat system, because that is what turns the ship into a multi-mission platform that can track threats, assign weapons, and fight as part of a fleet. Now go bigger, because carriers show you the same logic at a national scale. Huntington Ingalls Industries, through Newport News Shipbuilding, plays the central role in building and sustaining nuclear-powered aircraft carriers. Ford-class carriers like Enterprise and Doris Miller represent what happens when you apply modular construction, heavy lifts, and systems integration to a ship so large that the workforce itself becomes part of the story. And here's the part people don't expect. On complex ships like carriers, design changes during construction are not rare. Requirements evolve, technology shifts, lessons learned from earlier ships show up midstream. When a design change hits, engineers do not just scribble a note and move on. They assess the modification, trace impacts across structure and systems, develop a solution, prototype it, and test it, because on a carrier, guessing is not an option. Now walk into a different corner of the shipyard, the parts that don't look like ship parts yet. Structural components are fabricated in manufacturing shops using high-strength materials. Some massive parts come from specialized foundries that can produce huge precision castings. Newport News has a large foundry operation capable of casting metals like high yield and carbon steel, depending on what the component must endure. And this is where shipbuilding gets almost violent in the best way. To cast a major component, you create a mold. Melt metal at temperatures approaching 2,000 degrees Fahrenheit and pour it into shape. Then the cooling process has to be controlled because material properties are not a suggestion. They decide whether something holds under stress or cracks when it matters most. Some castings are quenched, rapidly cooled in water to increase toughness and help resist cracking under mechanical strain. That is not a fun fact. That is survivability being baked into the ship before it even looks like a ship. But building is only half the battle. The yard has to move it. Rigging is its own discipline inside shipbuilding. Cranes, hoists, slings, cables, hooks, specialized transporters. Every move planned because one sloppy lift can ruin a component that took months to fabricate. When you hear the term super lift, you are hearing about entire modules being hoisted in position because they are too large and heavy to assemble any other way. This is how flight deck sections and huge structural units get placed. It looks dramatic, but it is controlled choreography because the tolerances still matter, even when the object is the size of a building. And while all of this is happening, the ship is sitting on keel blocks. These blocks distribute weight, keep alignment true, and hold the structure stable as it grows. Even in a dock, gravity is still undefeated, and shipbuilders have to fight it every day. You've probably heard the phrase keel laying, especially for carriers. Traditionally, the keel is the backbone of the ship, running along the bottom of the hull from bow to stern to provide strength and stability. In modern modular builds, keel laying is often a symbolic milestone rather than the old image of laying one continuous beam. The real moment that matters comes later, so here's the question that keeps the whole process honest. When does the ship truly become real? It becomes real when the systems come alive. A ship can look finished and still be a dead city inside. Steel is just the body. The real ship is power distribution, controls, sensors, networks, firefighting systems, alarms, watertight doors, and the boundaries that make damage control possible. This is the point where shipbuilding stops being constructed and becomes integrated. It is also the point where the shipyard, suppliers, and Navy oversight teams get deadly serious because the ship is transitioning from assembled to operational, and this is where people misunderstand testing. Testing isn't one grand event at the end. It happens in layers. You test equipment, then you test the system that equipment belongs to, then you test how systems behave together, because warships are webs of dependency. Bring a major load online, and you change power behavior across the ship. Light up combat electronics, and you pull cooling, electricity, and network bandwidth. Push to speed, and you change vibration and noise, and suddenly sensors and systems can behave differently than they did at the pier. Now think of what that looks like in real life. A space gets energized, panels wake up, a pump starts, pressure rises, someone checks for leaks and listens for the wrong sound that tells you a line is not seated right. Alarms get triggered on purpose because you do not want the first real alarm to be a real emergency. This is how you turn a pile of systems into a ship that can survive being a ship. Oversight exists because the Navy does not want to discover problems when compartments are sealed and access is miserable. The earlier you catch a defect, the cheaper it is to fix. The later you catch it, the more steel you have to cut just to reach the mistake. That is why the build includes continuous verification, not as a bureaucracy, as self-defense. So, who enforces the proof? On the waterfront oversight side, teams associated with the soup ship world witness testing, track deficiencies, and make sure fixes actually close out instead of getting shrugged into the future. On the acceptance side, InServ acts like the Navy's hard evaluator. Does the ship meet the standard it was promised? Does it work as a ship, not just as a collection of parts? Now the sequence becomes simple to follow. First, you do extensive production testing while the ship is still in the yard. Then, you go to sea for builder's trials, where the shipbuilder runs the ship hard and the ocean exposes what the pier can't. Saltwater motion finds weaknesses fast. It also finds them early while the builder still owns the problem and can fix it without excuses. Then come the acceptance trials. This is where the ship proves it meets the buyer's standard. Deficiencies get documented and tracked for correction. The goal is safe, operable suitability for service, not a perfect showpiece. If the ship clears the right gates, you reach delivery. And this is where people get the timeline wrong. Delivery is a handoff of custody from the shipyard to the U.S. Navy. It is not a magical moment where the ship is instantly ready to deploy. It is the Navy taking ownership of a platform that now has to be trained on, stressed and shaped into an operational machine by the crew who will live inside it That crew piece matters because the shipyard builds more than combat capability. It builds a place where people will sleep, eat, stand watch, and respond to emergencies in cramped steel spaces filled with fuel, wiring, and equipment. A warship has to fight, but it also has to keep its people alive in the worst conditions. That reality is why so much of shipbuilding is obsessed with documentation, verification, and repeatable proof. After delivery, the ship enters the early life period where the Navy runs shakedown activities that deliberately push the platform, train the crew, and reveal what still needs adjustment. Then you hit the planned fix and finish window where early deficiencies get corrected in an organized way. This is how a new ship stops being a brand new object and becomes a trusted fleet unit. That's the end of this video. If you enjoyed this inside-out breakdown of how ships become Navy ships, make sure you subscribe so you don't miss the next one